Hi again, welcome back to China Manufacturing Decoded from Sofeast. It's Adrian here, and this time joined by our head of new product development, Andrew, once again. Andrew, welcome back.
Hey, Adrian, good to be here. Hi to our listeners as well.
Yeah, hello to everybody listening. And by the way, and I normally don't say this at the start of a podcast, but if you do enjoy the podcast, please give us a 5-star rating in wherever you're listening to the podcast, of course, because we love a good review and that helps to spread the word and get us even more lovely listeners. So, Andrew, today we're going to be diving into a really important topic, and I'm looking forward to picking your brain on how to actually run a pilot run.
Yeah, thanks, Adrian. I think that in the industry, there aren't really enough attention paid for a pilot run and how much
Mm.
money it can save and how much headaches it can prevent. A pilot run, really, what it is test before mass production. So you're trying to test the production in a very low volume way, and you're really trying to understand what are the kind of issues you could be facing that needs to be fixed. And by the way, usually you do that outside the schedule of the actual mass production, so you have plenty of time to debug the issues, fix the problems, tune the equipment, for example, calibrate the machines. So there's a lot of things need to be done that if you don't do pilot run, my God, it's really hard to tell what kind of issues you run into production. You could be pretty much having a production shutdown daily if you don't do the pilot run.
That sounds expensive.
Yeah, it does. And honestly, one of the things that I always emphasize that a lot of people don't know why pilot run is so important. Let's just say that you have to do this before the mass production, as I mentioned, to prevent any kind of massive issues that are hidden and no one knows about it, and then
Mm.
it could come out in the pilot run before mass production. So a few things that I have discovered, at least in my years of experience in electronics manufacturing. One of them is
Mm.
you definitely could do some planning ahead of time, and this pilot run will allow you to figure out, okay, what parts do we need, how many people we need, what kind of equipment we need, how much space do we need for manufacturing. I mean, it's
Mm.
amazing once you start doing the pilot run and you get into nitty gritty of just the planning alone. You'd be surprised what kind of discoveries are made, and you realize, oh my God, we are missing one big equipment. Okay, we can't do mass production for another 6 months. So, I mean, all kinds of things can happen. And then, of course, training. You need to train your people. You need to understand that you need to make sure that your production people, your assembly people, your quality control people, people who are in the receiving end of the material for mass production, people on the
Mm.
other side when they have actually finished goods, and how do you actually store these? How do you move the goods around? What kind of equipment you need to moving around while you are manufacturing, and on the actual production line? How do you assess what is good and acceptable, what is bad? Testing procedures, softwares, automation, jigs that you need. There's just so much things that needs to be done, and you need people to be trained to do all this. If there's
Mm.
a jig, someone needs to know how to run it. If there is some kind of production assembly, then there needs to be guides and work instructions. If someone needs to be testing, then he needs to know how to run that test equipment and the procedure for testing that particular product. So honestly, it could go on and on from one area to the other. And the next
Yeah.
thing is, for example, software and hardware readiness. So let's say design team on the hardware side already, the design has been locked in, the hardware is good to go. They're not making any more changes to hardware. Usually the software is always lagging. So there's always, depending on the product, anywhere from 2 weeks to a month or two of lagging could happen for software. And in that case, what are the hardware guys got to do? A lot of times you move those hardware guys to the pilot run. For example, there will be an almost exact manufacturing line, except they call it pilot. That means this is not part of the mass production. And those hardware guys actually start helping assembly team, production team to put together the actual production line for pilot run. And while the software is being completed, and once the software and hardware are completed, need to actually do one quick test internally before running the pilot run. Then, of course, manufacturing equipment. A lot of people forget how many equipment are in manufacturing. There are tons of equipment, and people get very busy in production line, and they forget to calibrate some of these machines. And all you need is one of those machines go berserk and not work properly. Then you have, lots of failures at the end of the line. So every single equipment need to be tuned up, calibrated per standards. And then people need to be trained on the manufacturing line to make sure that those equipment are running exactly how they are supposed to be. For example, solder temperature needs to be monitored and set. Some of the automatic pick and place machine need to be programmed. The correct components need to be placed in the machine. So equipment readiness is crucial for manufacturing. Well, how about the process readiness? I mean, the process itself is very critical. In order to know what and how you're going to manufacture the product, you need to have a very clear and concise manufacturing process. You need to know which process is going to be the most efficient and yield the highest at the end of the day. You don't want to do, for example, production on one of the PCBs on this building, and then another PCB needs to be, produced a mile away from in another building, and then somehow these two need to meet and go into the box. This is not efficient. So I'm exaggerating, of course. I think a lot of people have common sense, and that wouldn't happen. But I'm just, using that as an example of exaggerated example, how sometimes not efficient processes are in place that really, impacts the yields at the end of the day. And all you need to do is look at the whole thing on paper and figure out, okay, what can we do to improve the process so that we can be a lot more efficient and more productive, and maybe need less people to work, maybe automate some of the process, maybe not stop the process, keep it continuous. There are just all kinds of process improvements in production that needs to be taken into account that can really, really impact the efficiency of the process.
So a bit of process engineering included in this then.
Absolutely. I think it's manufacturing process engineers are famous for doing this type of job. It is one of the most critical roles in production, and process engineering and manufacturing engineers really focus mainly on the process, and then mainly on production equipment readiness, and then of course issues that comes from that. There's another thing that I have seen is or what come out of pilot run, which is extremely beneficial, is finding the issues. I mean, if you don't run the pilot run, how do you know what issues are you going to face? Are you going to just go ahead and put, let's say, 10,000 PCBs and then push the button, and at the end of the day, you have 10,000 PCBs all no good? Are you going to do that? That is just insane. Nobody should do that. So the pilot run allows you, with a small run, maybe even less than 100 units, you'll end up finding all kinds of issues. You find the issues with the pick and place machine, the pasting, the stencil issues. You'll find components missing or components are not fitting. You'll find soldering issues. The soldering machine is not actually soldering where it's supposed to, or the temperature is not right, or right at the time you're trying to run the process, somebody says, "Oh, wait a minute, we forgot to put the testing equipment right where it's supposed to be testing." So a lot of things could happen, and you're not going to find out unless you run pilot.
Yep.
And of course, how do you control your production? You're not going to know that unless you run pilot run, and then you say, well, you know what, I think it's a good area right here. We need to put an inspection point. I think it's a good area. We need to put work instruction right here. I think it's a good idea to put test point right here to make sure that the product is actually working before we assemble more into that product. Because you have some products that are extremely complicated, and it's almost like a jigsaw puzzle. I'm not sure what it's called. I think it's called the Russian doll. You put one and you put another one on inside and outside, and then you got these whole bunch of little dolls, inside another doll, and so on. You're familiar with that, right? So
Yeah.
I think that there are some designs, and because they're trying to save space in the design, they could have that kind of issue where you need to start assembling from inside out. And so as you're doing, you must control the process. You must test constantly to make sure that the one module that you just assembled is actually working fine before you add another module or put that module inside a bigger module, and so on. And so process control is crucial. And how do you do that? There are a lot of tools, one of which I think almost every one of our listeners can relate to. It's called control plan. It's without the control plan, you cannot follow what's going on in the production. Of course, SPC, statistical process control, for tracking each process, whether they are in control, out of control, control charts that tell you if processes are in control or out of control and what to do. And you could even time these processes. You could chart them daily, weekly, monthly, and then tracking the yields. In most well done production runs, there are actual yields monitoring daily, hourly. They track first pass yield, second pass yield. All of this is just extremely important. And at the end of the day, you also need, Adrian, automation and jigs need to be planned, because most often what happens is that you have a production run and people are assembling these parts. Well, sometimes people are in good mood. Sometimes they're not. Sometimes they're sleepy. Sometimes they're sick. Sometimes they're tired. And so what happens is that they produce variation on their work. One day they're in good mood, they're pressing it hard. Another day they're not. They kind of like put it in and they didn't press it all the way in. And so all of these creates variations that can impact the performance and outcome of how, basically the yields on that production run. So to alleviate that problem, you create jigs sometimes, which basically are low-cost way of automating things. If you have to press something, well, don't use the human press, the fingers, because someone is weak, someone is strong, and someone doesn't push enough, and the other person every time pushes breaks the component. So you use a jig where the operator puts the component in there, and the only way that that task is over is when the green light comes on, says, okay, good. And if the red light comes on, that means he or she didn't do it right and need to do it again. And so jigs are crucial in manufacturing assembly line. And then, of course, automation is unbelievably important. And you've got, for example, a product that has RF. I mean, how are you going to test it manually? It would be almost impossible. So you have these automated RF test machines that you put the equipment or the product exact point, they call it sweet spot, in the RF test box, and close it, push the button, and now you've got a testing that is totally standardized, and it's doing very fast evaluation of whether that product is meeting the RF specifications or not. So in my opinion, these steps that we just talked about are just tip of the iceberg on items that could result in benefits of doing pilot run.
Yeah, it's pretty compelling stuff. And I mean, you've mentioned things like statistical process control, and that's a whole topic in itself, isn't it? So
exactly.
We've written about this. I mean, Renaud definitely on his blog, qualityinspection.org, for example. So I'll dig out some good content about these different points that you've mentioned. And I mean, as you're mentioning, you could probably add more to it and the benefits of covering those with a pilot run. So now that we know, why to do a pilot run, you do also have some steps that you can share that you're suggesting that everybody that's listening, if you're thinking, okay, I'm going to start doing my pilot run and I want to follow, a good process. So there's a number of steps that you would suggest to follow and plan for before you start the pilot run.
Yeah, that's correct. In my opinion, based on my experience, I think these 5 steps are pretty much universal. It's a must. There could be more steps that you could add in there. These are basically the minimum. At the minimum, you must take into account all of these 5 steps from planning point of view. For example, before you run the pilot run, you need to think about, well, what is the scope of this pilot? Why am I doing this pilot? What is it that I am trying to run a pilot? Is it a component? Is it a PCB board? Am I trying to do this to qualify as supplier? Am I trying to do this scope of this is because I want to test the software? Or am I doing this because I want to test the manufacturing brand new test machine that we just bought, or pick and place machine we just bought? I mean, there could be millions of reasons why the scope could be changing all the time. And it's really important to know what is the scope, what's the intention of doing this test. And then number 2 would be, what are the main objectives? What is it that you want to gain from this test? And, if it is component test, right, you want to know a few things, right? You want to know the quality of the component. You want to know the component can handle the temperature of the solder, and you want to know if the pick and place machines can place this component properly. You want to know if the tape and reel are working okay with our machines, as opposed to maybe Fuji machine or some other machine. So there's so much, and that's just one example of a component. Imagine we're talking about PCBs and other areas of the design and manufacturing. So it gets really complicated. So you need to understand what is the whole objective and what is it that I want to gain from this. Then number 3 would be, who's going to do it? Who's involved? Who is in my team? Who's the pilot run team? Who's going to do what in this process? And that is extremely critical, because if you don't plan this right, and I mean, like, seriously, if you don't plan this right and you put someone in charge who doesn't know either the product, or is not aware of manufacturing, or doesn't know the design, or, for example, you're testing a component and he doesn't even understand the component, or is not a component engineer, you're going to look into, having all kinds of problems. So it's important you have the right number of people, and also so it's very important to have the right number of people, and you need to have the right competency of the people. And these people all need to be trained well, and they need to be aware of the process, what needs to be done.
Yeah, absolutely. I mean, who would you suggest should be in a pilot run team, roughly?
Excellent question. I think that for sure you need to have a director or someone who really high level manager or engineer or a project manager really understands the whole process from end to end, beginning to the end. And this is crucial, because you need someone to lead the team, what needs to be done. If it's just like you trying to start a party, you need someone to coordinate the party, right? You need someone to say, hey, who's going to buy the beer? Who's going to buy the cake? Who's going to buy the pizza? It is really important that he knows that we need pizza, we need music, we need cake. And if
sounds like my kind of party.
Well, yeah, I mean, in a way it is, actually, to be honest. It is so much rewarding when everything goes well and you push the button and 10,000, 50,000 units come out with almost, no issues, but it's almost impossible the first run. But I think you definitely need to have a high level engineer or manager type. And then you also need a lot of people with very good experience, at least medium to high experience on the product and manufacturing side of things.
Okay. So there's a couple more points to go, right? That was number 3. So who's involved in the pilot run?
Right. So one other item that I think that is very important is, do you have a plan? I mean, this is one of the key elements of doing anything, right? I mean, if I want to go, traveling, I want to know where I'm going to start my travel, where I'm going to end, and what I'm going to do in between. And that's exactly the same here. We definitely need to have a plan. And that plan would entail schedules, people, machines, parts, availability of several suppliers in case you run out of one part, who you're going to go to quickly purchase parts at that time. So this planning is crucial. And then the last point that I think is very important in this pilot run planning process is, the whole point of doing this is to get results, right? To do this pilot successfully. But how do you know you did it successfully? You need to do thorough evaluation of the whole process. You need to understand at every step of the process what kind of issues you ran into, how were they resolved. All of those need to be documented. I can't overemphasize enough the power of documentation, lessons learned analysis, corrective action plans, uh, you know, all kinds of documentation. The whole process need to be stored somewhere so people can go back and use it backwards for the next pilot run, so that each
Mhm.
time someone is running a pilot run, it's actually becoming a lot easier and it's already pre-planned. Objectives are clear, scopes are clear. You know
Mhm.
how you're gonna run, how many people, the same people or not. So once you have documented and have a process that is streamlined, I think you're going to get much better results.
Yeah, yeah. And a question springs to mind here. And I know that you can't give an exact dollar figure because pilot runs, as you've mentioned, will vary hugely depending on the goals and the sort of product being manufactured and a number of other factors. But I mean, in terms of costs, I guess you would agree that the cost of doing a pilot run is absolutely worthwhile as opposed to risking not doing it.
Absolutely. I think that if you didn't do pilot run, it's hard to tell depending on the type of the product you're running. But I
Yeah.
can assure you that for sure you're going to run into schedule overrun and the funding overrun, because of the fact that you're going to run into so many issues that at the least you will have to pay for a lot of people that are working double time, overtime, and trying to fix the issues, and then other issues that come up as a result. So, and then
Mm.
of course, if you unintentionally shift some of those units to customers, oh my God, then now you're looking at much bigger issues. You're looking at customer dissatisfaction,
Yeah.
brand being tarnished, possibly if there are reliability issues, you're going to have,
Mm.
you remember the Samsung issue that we talked about before. You could have problems, serious problems from the reliability or the use of the product that wasn't done right, and then you end up having massive returns that could actually turn the company upside down, and you could, instead of making profit, you could go out of business.
Mm, yeah, yeah, it's a serious thing, and the reason I mention this is because, and you'll have experienced this no doubt in Asia and I guess in China specifically, but also other Asian countries, it must have happened. There can be a bit of a tendency for some suppliers to sort of rush into mass production, and they might not necessarily be that keen on doing a pilot run.
Totally agree. And this happens over and over with new, let's say, entrepreneurs who are not aware of the whole process of, manufacturing and design and development. And they basically listen to these companies that are, small manufacturing companies that, unlike ours, they basically say, hey, yeah, what do you want to build? Yeah, sure, we can do it, and here it is, take this much
Mm,
time and this much money. They don't do any kind of a quality check, reliability testing, no pilot run for sure. And then basically they say, okay, you wanted PCB, here it is. You wanted this to
mm,
be put in the box, here it is. We can do it. The way we do things in Agilian and Sofeast is that we actually do it exactly how big box companies do. We definitely try and strive to run the same type of design and development first, and then manufacturing and pilot run. We do the whole gamut exactly how other big companies do. And,
yeah.
in conclusion, I want to say is that successful pilot run means that the mass production is going to run smooth. There will be less and less chance of major issues and risks. And I think that generally speaking, the risks will be known and or manageable. And then of course, hopefully, you'll have better yields, higher yields, especially first pass yield is very critical. And without the pilot run, on the other hand, you're running the risk of not knowing what issues you're going to run into, not knowing what kind of cost impact, customer impact, branding impact would have. And generally speaking, it could be a big mistake, actually. And you also mentioned something that I think you asked me about the cost. And I kind of mentioned the cost on the reverse side. But the cost of doing a pilot run, a lot of times is actually very affordable, not a whole lot. For example, if you have already, let's say, created a production line for a similar previous product, then the next pilot run would mean that you just evaluate what you've done before and maybe add another machine, some more assembly line jigs and automation and or operators. And so it could be very quick. And all of that, honestly, wouldn't cost a lot in terms of dollar amount. On the other hand, if you don't do that, the harm that it could do for the whole production and the yields could be tenfold.
Yeah. Well, if anybody listening is manufacturing here in 2023 and you're unsure about pilot runs, I think you must be thinking, well, that's it. Got to absolutely lock down doing a really thorough pilot run now. So thanks, Andrew, for bringing our attention to that topic. Really important one. And I've enjoyed it. I think the takeaway is good. We all know now some of the key points that we need to focus on when planning for a pilot run and, of course, why to do it. So it's a good one, Andrew. Thanks.
Yeah, thanks very much, Adrian. And until next time.
Thanks again for listening to this podcast brought to you by the Sofeast Group. We're on a mission to provide you with everything you need to manufacture effectively in Asia, including inspections, auditing, new product development support, contract manufacturing, 3PL warehousing and fulfillment, and much, much more across Asia's key manufacturing areas. Visit us at sofeast.com, that's SOFEAST.com, to learn more and get help. If you've enjoyed the podcast today, please do rate, review and share because it will really help others discover us too.